Number one, which is known as cross-sectional data structure. Cross-sectional. Suppose in this platform, 12 participants are there. And after completions of my today's session, if I take the perception about my class to all these 12 participants, then this type of data structure is called cross-sectional data structure. Because one participant implies one particular entity. So in this platform, if 12 participants are there, that means 12 particular entities are present. So it is one of the example of cross-sectional data structure. And all the 12 participants, one particular participant will be called as cross-sectional unit. Again, I am saying, out of these 12 participants, one particular participant will be called as cross-sectional unit. So when I am taking the perception of the research methodology class from the 12 cross-sectional units, then obviously the perception or the level of the satisfaction of the 12 cross-sectional units, it will vary, it will change. Whatever the perception one particular participants will be showing, the same perception will not be shown by other participant. So among the cross-sectional units, the response will vary. The response will vary. So this type of data structure is called cross-sectional data structure. I am just giving you many examples. Just I have given you one example, that is the number of participants. In this way, you can think number of countries. So one country implies one cross-sectional unit. You may say number of states, number of villages, number of companies, number of manufacturing plants, number of continents. So all these are the examples of cross-sectional data structure. So in case of the cross-sectional data structure, when we are taking the response from the respondents, respondents means various cross-sectional units. Whatever the responses we are getting from different cross-sectional units, it must be varied. It will vary from one cross-sectional unit to other cross-sectional unit. But always keep in your mind, when you are taking the responses from this cross-sectional unit, you are considering a particular time point. Suppose after the completion of today's class, I am taking the perception. That means I am indicating a particular point of time. I am taking the responses on a particular point of time from various cross-sectional units. Then your data structure will be called as cross-sectional data structure. So here the cross sections may be of individuals, cross sections may be of participants, trainees, states, countries, continents, manufacturing plants, various companies, various farms, etc., etc. So for the cross-sectional data structure, what about the specific software that we generally use in the galaxy of our research methodology, which is popularly known as SPSS, Statistical Package for Social Science. So for the cross-sectional unit, if in your research study, if you are dealing with various types of cross-sectional units, then you have to learn the specific software which is called as Statistical Package for Social Science. So this is a story of cross-sectional data structure and the relevant software that may be used by the researcher. The second category of data structure, is called time series data structure. The second category of data structure is called time series data structure. So, time series data structure, it is a self-explanatory word, self-explanatory. Time series data structure means when we are considering more than one point of time. But in case of the cross-sectional data structure, our discussions was restricted to a particular point of time. But in the case of the time series data structure, we generally consider more than one point of time. We consider many time periods, many time units, and your time period that you can express in terms of year, in terms of months, in terms of week, in terms of day, in terms of hours. So all these are the examples of time units, how the time will be measured, how you will do your observation. Suppose, just I'm giving you one example. Suppose we are considering per capita income. We are considering one macroeconomic variable, that is per capita income of our country for previous 20 years. So I am very much interested to know the trend of per capita income of India for previous 20 years. That means we are considering 2001 to 2020 time period. That means here the time period is more than one. Here my time unit we are expressing in terms of year. So how many time we are expressing? 20 years time horizon we are taking into consideration. So we are observing one macroeconomic variable, that is per capita income. That is my one variable, and I am observing this variable with respect to 20 time periods. Then this type of particular data structure is known as time series data structure. This type of particular data structure is known as time series data structure. And for time series data structure, what about the statistical software we generally use in our social science research is called eViews. eViews. E stands for econometric, and which is a combination of economics, statistics, and mathematics, so that we can truly measure a particular variable in a more sophisticated way, in a more scientific way. So that type of software is known as eViews. So the researcher or the academicians who are dealing with time series data structure, they have to learn eViews. This is very, very popular software that we use for the analysis of time series data structure. No, I have not presented, madam. I will give my presentation, then it will be visible to all of you. I am just trying to clear 3 types of data structure. So after that, I will present my presentation. So third type of data, yes, thank you. Third type of data structure is called panel data structure. Now you can understand why panel data structure workshop is essential. And I am very, very confused why there is a very, very few number of participants, because panel data structure is the important data structure nowadays for the research purpose in our social science research work. Now the question is, what is panel data structure? Because you have understood what is cross-sectional data structure and what is time series data structure. Now, if we combine these two things, if we combine cross-sectional data structure and time series data structure, then that combined form will be known as panel data structure. So what is panel data structure? When we are considering both cross-sectional data structure and time series data structure, then it is known as panel data structure. Now just I'm giving you one example. Suppose we are considering per capita income of our country for 20 years among 30 number of states. So one state means one cross-sectional unit. How many time periods we are considering? 20 time periods we are considering. So my data structure is a combination of time series data structure and cross-sectional data structure. Because being a researcher, we are considering per capita income among 30 number of states in our country for 20 number of years. So it is an example of panel data structure.
Sir, can I ask a question?
Yes, always.
Sir, these 20 states or 30 states in the panel data study, they will remain same or they will change?
Stravid, please once more, because the question is not clear to me.
Okay, sir, the participants in the panel data analysis, panel data structure, they will change or they will remain same?
They will change in respect of what?
Responses. For example, you are talking about per capita income.
Yes.
In the last 20 years, for the 30 states.
Yes.
So those 30 states will remain same, or you will change the constituents of the states itself?
Yes, yes. So now your question is very clear to us. I'm just giving the response. In this case, when we are considering, we are not considering 30. Suppose you are considering one state and you are considering 20 years and you are taking variable that is per capita income. So obviously, per capita income in the year 2000 in West Bengal, as well as the per capita income in the year 2020 of West Bengal, these will obviously change. So due to passage of time, the per capita income, this macro variable, the value of the per capita income, it will change across the states. Is it clear to you?
Sir, I understood, sir. The question was regarding the participants. If the participants change or if they remains constant, then in the time series data analysis, then we can say that it is time series data. But if the participants are changing, then time series data will suffer.
Yes. What you are telling, you are telling not about the state. You are now telling about the respondents. Obviously, the respondents means their perception, their attitude. So everything will change. Suppose when I was 20 years old, and on that time my perception, and now at this present age, my perception, it has been varied.
Right, sir.
Right? So the responses will also vary.
No, I am talking about respondents, because somewhere I heard that in time series data, the respondents are remaining the same.
Yes, you are the respondent, you are same. So obviously in case of the state, we are not changing the state.
Okay.
We are taking into consider 30 number of states. So
On a
we are
constant
not, we are not hiring any other extra state, right?
Okay.
All the 30 states are there. Now we are measuring the per capita income in different time periods.
Okay.
So in our data structure, we are considering cross-sectional unit as well as we are considering time units. That's why this type of data structure will be called as panel data structure. Yes?
Okay, sir. Thank you, sir. Thank you.
Yeah, welcome. Now the question is, for the panel data structure, whatever the software we generally use, that is eViews as well as Stata, STATA. So we can solve the same problem using eViews as well as using Stata. But if you use Stata, then you will get so many more options in comparison to eViews software. So in 5 days workshop, I will obviously use the Stata platform as well as I will also use the eViews platform. And after the 5-day session, obviously you can understand which software is comparatively better to you, and accordingly you will use that particular software. There is no hard and fast rule. For panel data analysis, only we have to use the Stata. But Stata is the very useful software for panel data analysis. So from this discussion, we can conclude that there are 3 types of data structure: cross-sectional data structure, time series data structure, and panel data structure. Cross-sectional data structure, specific software is SPSS, Statistical Package for Social Science. For time series data structure, the popular package is eViews, and for panel data, we may use eViews as well as Stata. Now I will show my PowerPoint presentation one by one so that you can understand. Is it visible to you?
Very much, sir.
Okay, thank you. So, as this is the first session, therefore, first we will clear our conceptions, and from second day onwards, we will use the specific software that is Stata from tomorrow. So today I will not show you the Stata, only just I will show how to what type of software we will use in case of panel data. So concept of panel data, I hope it is clear to you. So I will discuss concept of panel data, then structure of panel data set, then types of panel data. There are various types of panel data, usefulness of panel data, and what types of model that we will consider under panel data analysis. So the introductory topics of today's session. So I have already discussed these things. Panel data is a combination of cross-sectional and time series dimensions. And cross-sectional units, it might be countries, states, anything. Districts, cities, villages, farms, responsibles, time dimensions, year, month, week, day, hour, etc. So to generate a panel data set, we are required to collect data for a number of we have to consider. For a set of cross-sectional units. So it is combination of both. We are considering many number of time periods, as well as we are considering many number of cross-sectional units. So you will remember in this way, when you are considering many numbers or many time periods and many cross-sectional units, then your data structure is definitely a panel data. Just give you one example. Understanding part. In so here the major state and we are considering in 3 time periods, been considering more than one time, and we are to observe. These are our variables will be observed.
Dr. Saab, it seems the network.
One variable is.
Hello, Dr. Saab. Hello.
Yes. Yes.
Dr. Saab, I think there is some network issue. Your voice is not clear, sir.
Okay. Okay. Now it is clear.
Now it is clear, crystal clear, sir.
Oh, okay. Thank you very much.
Yes, sir.
So example, again I am repeating, right? No problem. So we are considering 17 major states. It means that we are considering 17 cross-sectional units, and we are considering 3 different time periods. That means many time periods we are considering. So it's a combination of cross-sectional unit, and time units. So it is a panel data. And in our example, we are going to observe three macro variables. One macro variable is rural poverty ratio. You have computed rural poverty ratio, RPOV. You have considered percentage of rural workers who have been employed in non-farm sector, not into the agricultural sector, non-farm sector. The percentage of rural workers in non-farm employment, this is your another variable. And you have also considered rural literacy rate, that is another variable. Now, when we are considering panel data, our basic objective is to predict the unknown variable. Again, I am trying to say, when we are considering the panel data structure, our basic objective is to establish an equation which will be used for the purpose of prediction of our unknown variable. That means dependent variable. So when we are considering three macro variables, from our domain knowledge, we have to identify which one implies dependent variable and which are basically independent variable. So from our domain knowledge, if I say that rural poverty ratio, this is my dependent variable. Rural poverty ratio, this is my dependent variable. And RNFW, this is my independent variable. And the rural literacy rate, LIT, this is also one independent variable. So in this case, we are observing one dependent variable and two independent variable, and our objective is to establish an equation through which we can predict rural poverty ratio, that is dependent variable, with the help of independent variable, that is RNFW and LIT. If you are dealing with this type of problem in your research work, then obviously you have to use panel data solution software, that is eViews or Stata. Next slide. The first thing is how to formulate your data structure. This is very, very vital. Otherwise, your software will not accept it. So when you are using Stata software, then first thing is you have to prepare your data set in your Excel file. And how the Excel file will be imported into the specific software, obviously I will show it. So first task is you have to prepare your Excel file so that it can take a look of panel data structure. So that's why I have written here structure of panel data set. So how will you prepare it? Just you open your Excel file and first you specify the cross-sectional unit. First, you have to specify the cross-sectional unit. You may note down it. First of all, you must specify your cross-sectional unit. Second, you have to specify your time unit. The first is cross-sectional unit. The second one is your time unit. So it is a combination of both state and year. So it is panel. Now we have to write our variables which are going to be observed in different states and in different time periods. General rule is, first you have to write your dependent variable or the dependent parameter. So we have assumed that poverty ratio, rural poverty ratio, RPOV. Here I have written POV, no problem. You may write also RPOV. So POV is your dependent variable. Then you have to write your independent variable. So you have considered two independent variables. So you have written here the name of those two independent variables. In this way, first in your Excel file, you give the name of the variables of the time unit of the cross-sectional unit. Now, how can you write the data? First, you will complete one state, then you will start another state. First, you will complete one cross-sectional unit, then you will start another cross-sectional unit, so on, right? So here, first we have considered Andhra Pradesh, Andhra Pradesh, Andhra Pradesh, because we have considered three number of time periods. That's why we have written one, first year, second year, and third year. So first we have written here AP, 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 then first year data of AP, second year data of AP, third year of AP, and the data you will write accordingly. So this is the data of the first year of Andhra Pradesh. This is the data of second year of Andhra Pradesh. This is the data of third year of Andhra Pradesh. And accordingly, you will again write the name of another cross-sectional unit. In this way, you have to cover the total 17 major states or 17 cross-sectional units in three different time periods. In this way, you will prepare your Excel file, and after preparing the Excel file, then obviously you have to give a suitable name so that you can find it later on. In this way, you have to prepare the panel data set in Excel. This is your first task. Otherwise, you cannot use the software. Next. This is very, very vital graphical representation I will show you. I have deliberately incorporated two graphs, and you have to understand it. Then it will be very, very clear why we use panel data, why we will use panel data. What is the logic behind it? So listen minutely. It is a very simple graphical representation. We have considered the education of our workers along the x-axis. Suppose we are measuring education or the level of education of our workers along the x-axis, and we are measuring the income of the workers along the y-axis. Again, I'm saying along the y-axis, we are measuring the income of workers, and along the x-axis, we are measuring level of education of workers. Now the question is, what is the role of panel data? Panel data clearly demarcate the cross-sectional units, because one cross-sectional unit and the characteristics of one cross-sectional unit is different from the characteristics of another cross-sectional unit. So here the assumption is, for your understanding purpose, suppose there are two types of workers. Suppose there are two types of workers.
Professor
Yes.
Biswas, sorry to disturb you. The presentation is not aligned properly, so we can see only a portion of the presentations.
Yes, but what I'm trying to say,
Right, sir.
there are two lines, right? There are two lines. This line is for regression line for female workers, and this upper line, this is the regressions line for male workers. And initially I have told you, along the y-axis, we are measuring the earnings of the workers, and along the x-axis, we are measuring the level of education of workers. Is it clear?
Yes, sir.
Yes, yes. So the complete picture I have not incorporated. That's why it is not visible. One side is visible. So I'm just explaining so that you can understand. So here, what we are assuming, there are two types of workers. One is male worker, another one is female worker. So male worker is your one cross-sectional unit, and female worker is another cross-sectional unit. Clear? Now, what we are observing, the regressions line of male worker, this one, this is higher than the female worker. So from this graphical representation, we can say that the educated male worker and their earnings is comparatively more rather than the earnings of female workers. Now, for the male workers, we have established a separate regression line. And for the female worker, we have also established a separate regressions line in case of panel data structure. But if you do not know the panel data structure, then what will happen? That is the intention, to show you what types of mistake that the researcher commit frequently. So again I am saying, in case of the male worker, suppose this is your y-axis, so the intercept, that is this to this portion, that is your intercept. Yes. And in case of the female worker, the intercept is this to this portion. This is the intercept of female worker, and this is the intercept of male worker, right? And the second is, when we establish regression equation, two things are very important. One is intercept and the second one is slope. Intercept means constant. Intercept means which is constant, and slope, it varies. So now in this case, what is happening? The intercept of male worker is this portion to this portion, and the intercept of female worker is this portion to this portion. Very good. And the second is the slope of male worker, that means angle, the angle, y-axis and this line, the angle, this is the slope of the male worker, and this is the slope of female worker. That means here the slope is also positive in case of the male worker, and in case of the female worker, the slope is also positive. The slope is also positive. But if we do not consider the panel data structure, then what types of mistake we commit, that I will show in the next graphical presentation. So again I am saying, in this case, the slope is positive in case of male worker, and the slope is also positive in case of female worker. And the intercept in case of the male worker, it is higher, and the intercept of the female worker, this is comparatively lower. Now, if we do not consider panel data structure, then what will happen? What types of mistake we do? Just you observe this minutely. Observe this minutely. I am explaining it. This is the line that you have already established for male worker. This is the line that you have established, suppose, for male worker. And this is the line, regression line. And why regression line we established? For the purpose of prediction of our dependent variable or unknown parameter. And this is the regressions line for female worker. Female worker. Now, if we do not consider the panel data structure, if we combine the male worker points, all the coordinates of the male worker and all the coordinates of female worker, if we combine this, if we do not classify, if we do not consider the cross-sectional units, we are considering all these are the points, and we have to establish a regression line. We have to establish a regression line. So how this regression line can be drawn? If some points are here, some points are here, and some points are here, then covering all this regression, all these coordinates, for covering all these coordinates, obviously the line will pass in this way. In this way. And this regression line is called pooled regression, because you are not classifying various cross-sectional units. That means you are violating the assumptions of panel data. You are just trying to establish one regression equation, and on that particular regression equation, you are trying to predict the unknown parameter. But what types of mistake you are doing? Suppose your regression line is this, because you are trying to cover all these coordinates. then what is happening here? What is happening here? The great mistake that we have done. What type of great mistake? Just we look at the previous figure. In this case, the intercept, yes, it was clear, and the slope was positive. The slope was positive. That means if educational level increases, then the earnings will also increase. But what is happening here? When you are drawing this regression line, your slope is becoming completely negative. From positive to negative. It is positive. Here the slope is positive. Here the slope is positive. When you separately consider female worker and male worker, that in the previous case. But now your straight line or the regressions line, it is from left to right. This is downward. Clear? So
you mean to say, sir, the third line, which is with negative slope, it is for
yes,
combined data of males and females.
Yes, that's why we have written regressions line using pooled data. Pooled means when we are not segregating. When you are not segregating. In case of you, male and female, there is no difference. Only you are taking the earnings at different level of education. But you are not saying for the educations of male, this is the earnings of male. In this way, you are not classifying. Then you are taking the pool data, and accordingly, if you try to establish the regression equation, it will give us the misleading result that we generally do. And that is the greatest mistake. And on the basis of that regression equation, we try to forecast, we try to predict the unknown parameter with the help of our some independent parameters. That's why when you are considering the cross-sectional unit as well as you are considering the time units, then obviously you have to apply the panel data structure. Otherwise, your regressions equation will not be accepted universally. That is the greatest mistake that the researcher commit.
Sir, in this case, what is happening is we are defining the problem later on after collecting the data for male worker and female worker. Later on, we are combining the data. So when we formulate a problem, then we should have taken the pool data itself, and we should have gone for this regression line with negative slope.
Yes. Let me say. Yes, that's why being a researcher, you should be very, very cautious what types of data you are going to collect. So ab initio, if you are very alert, then you will not do this type of mistake. Clear? So when you are considering, you have to think a research design. What types of data structure will be in my case if the problem is like this? Because you are considering time units and you are also considering the cross-sectional units. So there are more number of cross-sectional units and more number of time units. So obviously your data is panel data. Therefore, you have to structure your data set in this way using Excel. So there will be no mistake. Understood?
Yes, sir. Understood. But, sir, first of all, why the data was segregated for males and females then?
Why the data is segregated for?
For drawing the regression lines for males and females.
Yes, because male and female, because you cannot say the male equal to female.
That is okay.
Right? You cannot, you cannot say West Bengal equal to Bihar. You cannot say.
Understood, sir. But
right.
why we drew the regression lines for males and female workers separately then?
That is the uniqueness of the panel data.
Okay, just for understanding.
Yes, that is the uniqueness of the panel data.
Okay, but sir,
so if you use the panel data, Then
Yes, sir.
3 types of model you can develop. That I will discuss later on.
Okay, sir.
You
Also,
just say me whether the regressions line, graphical representation, these are clear to you or not.
yeah. But sir, I could not understand when the slope was positive for male worker as well as female worker.
No,
Then
that I have not told you. That I have not told you.
in
I
this,
have told you, in case of male, it is positive. In case of female, it is also positive. But when you are considering the pooled, then
yes,
both
sir.
are becoming negative.
So, sir, how can it be possible, sir, that that it becomes negative from positive?
That is your mistake.
Okay.
Because you have draw your regression equation in this way. Because why you are your pooled regression equation in this way? Because here the least square method principles is applied.
Okay.
Clear? So generally in your
Okay.
BCom class, generally in our BCom class or MCom class, basically what we do the pooled regression,
Okay. Understood.
right?
Okay. So, based on the least square method, the regression line will
Exactly.
be in this fashion.
Yes.
Okay.
Yes.
Okay.
Obviously, your line will be like this because
Uh,
here are some points, the closest distance from this line, right? Closest distance from this line in this way.
okay.
It
Okay.
is,
Okay.
you are not establishing, the software is
Software is
establishing.
established. No,
Yes.
visually also now understood. Okay. Least square
Yes.
method. Okay.
Yeah.
Understood.
And that is the main turning point, right?
Uh-huh.
Main turning point. Just to look here, all the slope is positive. And here also you are drawing a regression equation,
No, sir,
right?
in this case, what is happening is the points are closer to the regression lines.
Yes, obviously.
Right, sir?
But when you are combining, then there is no demarcation between male and female.
Yes, sir. Understood. Okay.
That is the beauty. That is the beauty of the panel data. Yes.
Not beauty. It is magic.
Thank you. Thank you very much.
Thank you.
So I was some doubt whether this graphical representation will be understood by the participants or not. So if it is understood, then it is okay. Then you can understand all the lessons, different days of mine. I am sure. Now the second, yes, may I audible? Hello?
Yes, sir.
Audible. Okay. So next is types of panel data. So you have understood what is panel data. Now you are trying to classify the different types of panel data, but only for your understanding purpose. But on the basis of the classifications of panel data, the model will not be deferred. The model would not become different. Although we have to understand there are 4 types of panel data. The first is called balanced panel. And what is balanced panel? The condition is each cross-sectional unit has same number of time series observations. Each cross-sectional unit. Just you think about the first example. Suppose we are considering 17 number of states, and for all state we have considered 3 number of periods. So that is your balanced panel. But in case of unbalanced panel, each cross-sectional unit does not have same number of time series observation. Suppose in case of West Bengal, you are considering 4 years. In case of Andhra Pradesh, you are considering 5 years. In case of Himachal Pradesh, you are considering 7 yards. So your panel structure is called unbalanced panel. On the basis of the number of your observation across the cross-sectional unit, the panel data is of two types. One is called balanced panel and another one is called unbalanced panel. Again, I am saying, in case of balanced panel, each cross-sectional unit has same number of time series observation. If in case one state you have considered 3, and for 17 number of states you have considered 3 number of periods, then that type of panel is called as balanced panel. And if you are considering different time periods for different types of states, then it is called unbalanced panel. So whatever the first example I have cited, that implies our data set is an example of balanced panel. And another type of classification, that is short panel and long panel. This is another way of classification. And what is the way of this classification? The number of cross-sectional units is greater than the number of time points. The number of cross-sectional units is greater than the number of time points. Just to remember the first example, we have considered 17 number of states. That is, the number of cross-sectional units is 17. But the number of time periods, it was only 3. So if the number of cross-sectional units, that is 17, if it is greater than the number of time point, that is 3, then that type of panel will be called as short panel. Short panel. So the example, whatever the examples I have given to you of various types of states, that example is of balanced panel as well as short panel, because the number of cross-sectional units, it is greater than the number of the time points. But if reverse situation arises, conversely we can say that if the number of time points, if it exceeds the number of cross-sectional unit, suppose you are considering 5 states, but you are considering the variables for 10 years. Your cross-sectional unit is 5, but the time period is 10 years. So that type of panel will be called as long panel. So in case of long panel, the number of time points, it exceeds the number of cross-sectional units. In this way, we can classify different types of panel data. It might be balanced panel, unbalanced, short, and long panel. I'm just going to my next slide. The usefulness of panel data. One by one I will discuss. You listen very minutely. What are the importance of panel data? The first important is it considers the heterogeneity among the cross-sectional units. That means in case of pool data, what I told you, there is no classification of cross-sectional unit. But when we are considering panel data, so panel data, it considers all the cross-sectional units under study are different from each other. So it considers the heterogeneity among the cross-sectional unit. That's why we have classified the workers on the basis of gender. Some are male, some are female. You may classify also the workers on different basis. On different basis, you may also cross-section your cross-sectional unit. That depends on the nature of your research work. Basically, it depends on the objective of your study. So panel data, the first important is it considers the heterogeneity or the variability among the cross-sectional units. That is the first importance. And the second important is panel data enhances both quantity and quality of data. How? Because when you are considering 17 number of states, listen minutely, when you are considering 17 number of states and for each state you are considering 3 time periods, that means you have 51 types of combination or 51 types of observation. But if you are not considering, if you are not classifying the cross-sectional units, you are not demarcating the states, then what will happen? There will be no such variation. So if the variation is more, then there is a less chance of collinearity. That means the relationship among the variables. Again, I am saying, if you consider the panel data, it creates more variability in the data set, so less collinearity among the variables. If the differences are more, obviously the relationship, it would be less. So this is the common problem that we face. We have established the regression equation, but there is a high degree of relationship among the independent variable. So your regression equation will not be accepted. If the collinearity problem is there, if there is a problem of multi-collinearity, so there is a slight difference between collinearity and multi-collinearity. Suppose you have considered 4 independent variables, A, B, C, D, 4 independent variables, and you have checked the collinearity between A and B. So collinearity only exists between 2 independent variables, that is A versus B, A versus C, AD, BC, BD, CD, in this way. But when you are saying that your data is a problem of multicollinearity. That means A versus B, A versus B, B versus C, A versus C. In this way, if so many collinearity is there, then it is a case of multicollinearity. But if only one pair of independent variables are correlated, suppose A and B, or B and C, or C and D, any one, then it is a case of collinearity. Otherwise, you may also say that your data is a multicollinearity problem. So if the variation
Sir,
in
can you please explain
the
this?
data is more,
Hello, sir.
yes,
Can you please explain
yes,
this multicollinearity business?
yes, I'm again saying. In case of multicollinearity, that means so many collinearity you are observing among the independent variable. Suppose there are 4 independent variables, A, B, C, D, and you have observed that there is a collinearity between A and B and C and C and D, then it is a problem of multicollinearity. But if there is only one problem of collinearity, suppose there is a relationship between only A and B, but not B, C, C, D and other things, then it is a case of collinearity. Clear? So this is the difference between collinearity and multicollinearity. In a very layman language, what we can say that when you are considering only 2 independent variables, then it is a case of if relationship exists between these 2 independent variables, then it is a case of collinearity. But if you are considering more than 2 independent variables in your study, then so many combination of relationship may arise. Then that is the case of multicollinearity. But if you consider the panel data, then as the variation or the variability in the data set will be very high, so there will be very less chance to occur the collinearity or multicollinearity problem. Because regression equation, if multicollinearity problem arises, if the independent variable themselves are related, then what is the utility of that regression equation? Clear? Hello?
Yes, sir. Understood, sir. Thank you, sir. Okay,
Yes.
so
Yes.
in case there is collinearity between 2 variables, then we have to
Yes.
merge those variables, sir.
If you merge those variables,
Yes, sir. If there is a collinearity between A and B, then should we merge
yes,
those A and B, sir?
yes. If you can manage in this way, you can do it. But obviously, you have to consider when you are merging it, then whether the intentions of your study, whether whatever the variable you have identified, its uniqueness is going down, right?
Okay. Okay, sir.
So that's why when the multicollinearity will be arise, then either you have to drop this variable or you have to think in another way. So many options are there to remove the multicollinearity problem, right? This is not only the way that you can merge it and so that multicollinearity problem will be removed. This is not like that. So as a consequence, more efficient estimation, that means predictions of unknown parameters of the model becomes possible when you are considering panel data. And the third point is, panel data sets are better able to study the complex issues of dynamic behavior. So any complicated issues of dynamic behavior. That means the behavior which is frequently changing. Just I'm giving you one example. Suppose in your research study, your intention is to show the impact of technological innovation. Show the impact of technological innovation on the companies. Then only the cross-sectional study will not help you. Because if you do not consider many number of time periods, you cannot say the impact of the technological innovation on the companies. So when you are going to measure the impact of technological innovations on various companies, that means we are considering cross-sectional units, as well as to measure the impact, you have to consider more number of time periods. If you only observe the one time period, then you cannot say that there is a impact of technological innovation. When you are going to measure the impact, at least you have to observe 2 years, 3 years, 4 years, more than 4 years in this way. So different types of dynamic behavior that can be betterly studied with the help of the panel data sets. That's why I have stated here, panel data sets are better able to study the complex issues of dynamic behavior. So fourth point is also more or less same, the complicated behavior model. That means if you can study the complex issue of the dynamic behavior, then obviously you can develop the complicated behavioral model on the basis of the complex issues of dynamic behavior. So number fifth point, identify and measure effects that are simply not detectable, in pure cross-sectional study or pure time series study. So some social issues are there, and if we are properly going to address the social issues, then sometimes we have to consider the cross-sectional units as well as time units. Only the cross-sectional study, it is not suggested, or only the time series of study, it is not also recommended. Just for example, I have written here one statement. Suppose the objective of your research is role of union to enhance the wage of workers. So if you want to know the changes of the wage of workers, then only one time period, it is not enough to measure the changes. At least you have to take 2 number of years so that you can measure the change. So if you want to measure the change, then more number of time periods is required. And it is also true, more number of workers you have to take into consideration. If you study only one worker and you study 10 years of that particular worker, and you are saying that, sir, the particular worker's wage has been increased, that's why we can say that there is a strong role of union. No one will accept your research. So if you want to prove the role of union, whether they are effective, whether they are fruitful to enhance the wage level of the workers, then you have to consider many number of workers as well as many number of time periods. Then you can prove that whether the union has an impact on the enhancement of the wage of the workers, right? So many type of complex societal problem that can be solved using panel data analysis in a very, very scientific way. That's why if you want to publish any good paper, in any good journal, obviously the Scopus Index journal, then if you apply the panel data structure and if your conception is very good, then I am sure your paper will be accepted by high quality journals. That is my commitment. So you basically try to learn the panel data structure, your life will be changed. Panel data structure. So this 5 days workshop, it will be very, very fruitful for you if you give your full concentration on the lectures that I'm presenting. So the next is,
Sir, in case of this, in case of a union, panel data, how panel data will be framed by taking some variables?
Excel. Yes.
More variables also?
Yes. Just you consider my slide. Just you consider my slide. Then you think. So your thinking process would become easier. Suppose state means cross-sectional unit. So here you will write what? Worker, number 1, number 2, number 3. How many workers you are taking? You just write here. Suppose number 1, worker number 1, worker number 1, worker number 1. Here, suppose you are considering 3 here, 1, 2, 3. Suppose you have taken wage, you write the wage. Suppose you take an incentive, you take the role of the trade unions in this way. Clear?
Okay, understood. So it is a net matrix of variables.
Exactly.
And okay.
Exactly.
So that means all the parameters are considered in panel data structure.
Exactly.
Thank you, sir.
Thank you. Next. So there are 3 types of model that can be established using panel data structure software, and we will use, initially I will apply the data from tomorrow, and after establishing the model using data, then I will show how this type of model can be established using eViews. Now the question is, why we will learn these 2 software? Because some researcher, they already know eViews. So for them, it will be very much fruitful if they use the same software, eViews software, in order to solve the panel data problem, then it will be easier for them. And for the learners who do not know about eViews, so obviously they can also understand the eViews as well as data. So it will be added advantage for them also. So there are 3 types of model that can be dealt using panel data. One is ordinary least square. This is called pooled. Pooled regression. So that's why what I have written, we assume that intercept and slope remain unchanged across cross-sectional units and over time. This is a very, very important statement. Again, I'm just explaining. When we are considering normal OLS, ordinary least square, or sometimes in some books, we write it as pooled regression equation. Pooled regression equation. In case of pooled regression equation, our assumption is our intercept. That means when you are considering the regression equation, there are 2 things. One is intercept, and another is the slope. So intercept, it does not change across cross-sectional unit. That means what is our assumption? Our assumption is all cross-sectional units are same. There is no difference. We are pulling it. So intercept and slope remain unchanged due to the change of cross-sectional unit. Another assumption is the intercept and the slope of our regression equation, it will be also unchanged. It will not change due to change of time. So we are not considering cross-sectional unit, as well as we are not also considering the time units. The intention is we are violating the assumptions of the panel data structure. That is the combination of cross-sectional and time units. So that's why this model is also basically known as the constant coefficient model. Basically, what is the coefficient? The coefficient is nothing but the slope. And what is your assumption? The slope remains same. It will not change. That is our assumption. But other two models, one is fixed effect model, another is a random effect model. So under fixed effect model, listen very minutely, under fixed effect model, our assumption is the intercept is allowed to vary across cross-sectional unit. Just I'm showing it again. The intercept, this is the male worker, this is the female worker. The intercept, in case of female worker, this is the intercept. In case of the male worker, this is the intercept. So our assumption says the intercept is changing across the cross-sectional units. Intercept is allowed to change across the cross-sectional unit, but the intercept does not change. It remains constant over time. So why the intercept is changing? The intercept is changing due to the change of the cross-sectional unit, because all cross-sectional units are heterogeneous in character in reality. All the cross-sectional units are not homogeneous in nature in reality. But this intercept is not changing due to the change of time. So the model is called fixed effect. Why it is fixed effect? Because we are assuming that it is time invariant. The intercept is time invariant. It does not change due to change of time. In that case, the model will be called as fixed effect model. So we don't know whether fixed effect model we will accept or whether the random effect model we will accept. So how we will take the decision? Using the software. The software will tell you which model will be the perfect model for your case. So always do not think that either fixed effect model or the random effect model is the best model. Sometimes the software may suggest you the OLS model is the best model. So how you will take the decision? You have to compare between OLS versus fixed, OLS versus random, fixed versus random. So many options are there in the software, and we will learn how to use this so that we can betterly establish the most scientific regression model for the prediction purpose. So in case of the fixed effect model, the intercept is allowed to vary across cross-sectional units, but the intercept assumed to remain constant over time.
Sir, you are saying intercept is assumed to remain constant over time. So this intercept is for the pooled data, right, sir?
Yes.
And the intercept for individual cross-sectional unit, it is different, right, sir?
It is different, right? Exactly. So the intercept is allowed here, but the time invariant is there. But in case of the random effect model, it is assumed that individual effect of intercept is a random variable with a mean value, with a mean value. As this model considered individual effect as a random variable, hence the name is given random effect model. Again, I am saying it is assumes that individual effect of intercept, individual effect of intercept, it is nothing but a random variable with a mean value. So in this case, what is the difference? In the fixed effect model, we are not considering the mean value of the intercept. But in case of the random effect model, suppose there are 10 cross-sectional units, so we are getting 10 random variable, and after that we are taking the mean value of those values of the random variable. So that's why this model considers individual effect as a random variable, hence the name is given random effect model. So from tomorrow onwards, we will learn how to establish this model. But tomorrow's class, I will focus on different basic commands that you must know when you are using Stata software. It is not like that only the Stata software you will solve the regression model. No, so many options are there, and you may, if you use this option, then you can get various types of statistical results. So tomorrow's class, I will focus on various types of basic commands that we will give using the Stata software. So yes, now just I'm showing how the data will be imported into this software. Just I'm showing it. Just look at this. Suppose this is my Stata. I am just clicking here. This is the structure of the Stata software, and this is 13 version, STATA 13 version, and there is one option that is statistics. This is used for analysis purpose. You know that in case of SPSS, one particular option is there, that is analyze. But in case of Stata, for analysis purpose, the main icon is statistics. Statistics.
Sir, this software Stata is open source software, sir?
Yes, open source software.
Okay, sir. So, sir, which version we have to download, sir? 13 version?
13 versions, you may also try for 13 versions or 12 versions, no problem.
Okay, thank you, sir.
So, suppose we have, just you click here, suppose we want to import one Excel file. That's why you just go to file, then one option that is import. This first is file, then import, then Excel spreadsheet, because you are trying to import the Excel file. Just to click here, go to browse option for searching. Yes. Now already one Excel file is there from day one. Just to click here, then you open, and already you are showing the data. Just you click on here, import first row as variable names. First row as the variable name, company, year, price, repair, sales. Just click here. Then just click on OK. Your software has already imported the data. So how can you know it? Just you type one command, describe. You have to remember all these commands. So obviously in tomorrow's class, I will show you various types of commands. Just for your curiosity, I am showing it, what type of software it is. Just click on enter. What you are showing? Every description have been given. Your variable name, company, year, and the name of the variable, price, repair, sales. So just I am going to my Excel file from day one. Yes, this is my Excel file. This is my Excel file. I have taken the company as cross-sectional unit. How many company I have taken? 6 companies. 6 companies. How many number of years I have taken? 2000 to 2010. So first I have written 1, 1, 1, 1, 1, 1 up to this. Then year 2000 to 2010. Then I will start second company. And what types of variables I have taken? Price, repairs, and sales. Right. So these are my variables. So how many observations are there? 6 companies. And for one company, we have considered one company. We have considered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 years. So for 6 companies, we will be getting how many combination? 66. 66 observations. Just you look here, 66, because it is 67, because one cell has been occupied by these variable names, right? So therefore, the total number of observation is 66. And when you are showing the software is already given here. The number of observations. How many observations? 66. Number of variables. How many variables? One is cross-sectional unit, another is year, and 3 variables. So total 5 variables. 5 variables. So all these things will be shown when you just given the command describe. So many commands are there. So one by one, I will show you in tomorrow's class. So thank you very much for your kind attention to my lectures. And another thing, I will also give my PowerPoint presentation. I will give my PowerPoint presentation as well as Excel sheet to Shivangi madam, so that Shivangi madam will circulate among all the participants. So thank you very much for your patient hearing.
Biswas sir,
Yes.
thank you. It was really wonderful session.
Thank you.
Only,
Welcome.
only
Yes.
thing is regarding softwares.
Yeah. So that problem I cannot solve it.
Okay.
I will show you the software. Yeah.
Because Biswas sir has written that this software is not open source software.
No, open source. You just try for it.
Okay, sir. Stata. Yes. EViews is only student version is free.
So you also search for student version. Is there any student versions of Stata or not?
Yes, sir. Yes, sir.
Yes.
Okay. Thank you, sir. Thank you very much,
Yeah.
sir.
Okay, welcome. Welcome, madam. So tomorrow I will definitely start at 5:30. It would not be late, because I waited 26 minutes. Yeah. Yes. Okay, thank you. Thank you very much.
Thank you, sir. Have a nice evening, sir.
Okay.
Thank you.
good
Have a
night.
nice evening. Thank you,
Good night.
Dr.
Good night.
Biswas.
Okay.